All right, hello and welcome to another video of the MSU Denver video walkthrough of the Elementary Acupuncture Study Guide. In this video, we're going to be talking about word problems, and really, honestly, word problems in general, but really in particular for this study guide and for this test. The math themselves is pretty easy. Once you figure out what the question is asking, right? The math is really easy for this test, for this study guide. From the word problems, it's really just figuring out what the word problem is asking and kind of trying to figure out how to set it up. But compared to what we'll be doing, the math itself, and you'll see, is actually very easy. And so if you're following along, we're on page 28 of the study guide. And at the top of page 28, there is a section about keywords to focus on. And it tells you what words mean addition and multiplication, subtraction, division. And so I'm not going to go over that. I'm not going to write it down. Honestly, the more you do word problems, the better you'll be, and you won't have to look at that section, and that's good because you're not going to have that stuff on the test. But as you're following along, whether you're following along with myself or you're just doing it on your own, I really suggest you have that page open and you kind of get used to what those words mean. And so definitely reference that as we're going through. But it's there, and I'm not going to rewrite all that stuff down. And there's like 16 or 18 problems in this section. I'm not going to do all the problems. I'm not going to do half the problems. I'm going to do every fourth problem, because even a word problem, to kind of walk through it just takes some time to kind of set it up. So I'm not going to do everyone, and I really don't want to do everyone because the more y'all do on your own, the better you'll feel, the more comfortable you'll be, and that's really what it's all about. And so I want to leave a lot of word problems. And Ron, honestly, if you get through all these and you're like, I'm still not feeling comfortable, look some up. You can find them on Khan Academy, and there's YouTube. You'll find some good word problems for the Elementary Acupuncture Study Guide. So there's other ones out there, and I'm just going to be doing probably every fourth one, so that you can do some on your own. And so let's just get started, and we'll go. And you'll see that the math itself is actually pretty easy once you figure out through the keywords what they're asking. All right. So number one, if you're following along, and I definitely suggest you follow along for this section, because I'm not going to write out the problem, all the words to the problem. But number one, and I keep stopping and kind of clarifying stuff. But for this and different problems, some problems it doesn't work for. But I like to draw stuff out, and if it doesn't make sense to draw it out, okay, well, don't draw it out, right? But for this problem, for this section, for the word problems, whether it's this test or whether you're in chemistry or physics, if you talk to people that do well in those classes that are like physics majors or chemistry majors, they'll all tell you, or they should tell you, that drawing stuff out helps a lot. And so I'm gonna, if it makes sense to draw stuff out, I'm gonna draw stuff out on these questions, but I'm not gonna write them out. And so I'm actually gonna scroll down so I have a little bit more room right away. Number one talks about, let's see, Ralph the farmer wants to fence off a rectangular area of 100 square feet on his farm. He wants the closest side to his house to be 25 feet long. How many feet of fencing does the farmer need to purchase? So a couple keywords that we're looking for in there is he wants to fence off an area, right? And so area, and so here's some things that you want to know for the test, is that area equals length times width. And maybe that, you're like, duh, but if you're not, that's something that you really want to be familiar with. Another thing I want to be familiar with is that the perimeter, I'm going to have as P, and I'm talking about the perimeter of a rectangle, and that's, if I kind of sketch it out over here, let's pretend that's a rectangle, and we'll call this L, and this L for length, and this is width, and this is width, and if I want the perimeter, then it's 2 times L, whatever that is, plus 2 times W, right? And that'll give us the area around the outside, not the area, but kind of the length of the perimeter. Really, perimeter, all that means is kind of like the border, right? And for a rectangle, this is what the equation is. If it were, some odd shaped, thing, I would just add up all the sides, and they would have to give you a lot of the sides or whatever. But for a rectangle, that's what we care about now. And so it's 2 times length plus 2 times width. So those are two kind of formulas that you want to just have in your head. You also want to have, and I don't think I'm not sure if we're going to go over this one. I'm not sure if they give it to you on the test, but the area of a circle is 2. Oh no, it's not. It's pi r squared, and then the circumference of a circle. And again, I don't need I'll write that out, circle. The circumference of a circle is 2 pi r. I think they may give you those on the test, but definitely know the area of a rectangle, the perimeter of a rectangle. All right, so moving on. It says it wants the area to be, so I'm going to write this down. It says he wants the area to be 100 feet, so I write down everything I know. 100 feet, and we can square that because it's supposed to be squared. You know, that's not a big deal on this. But it says square feet because area is going to be square feet. And then it says he wants the side, so if I draw, I'm just going to sketch that out, and I'm going to say, well, this is his house, right? And it says he wants the side closest to his house to be 25 feet long. So if I make some rectangle over here, and maybe this is accurate, or maybe the side closest to his house is shorter, I don't know, but I'm going to write this as 25 feet. Okay, and this is why I like to draw it out. Okay, so I got that. It says the side closest to his house is 25 feet. Let's see. And that's all the information that they give us, but they want to know what the perimeter is, right? Okay, so let's talk about what we know and what we can find out. Well, whether you say 25 is the length or the width, it doesn't really matter, but I'm going to call it the length. And because it's a rectangle, I know that this side also has to be 25. And then I don't know what the width is. Okay, so I'm going to write that as just W for now. But I do know up here that the area, which is 100 feet, 100 square feet, is equal to length. I know length, it's 25, times, well, I don't know what W is. Okay. And so, well, how can I figure out W? Well, this is again, the math is pretty simple here. If I want to solve for W, I just divide by 25. And if I divide both sides by 25, I get the width is equal to 4. So that means that this has to be 4 right here, and that means that this also has to be 4 right here. And now, you can use the equation of the perimeter, because that's what they're asking for, right? How many feet of fencing does the farmer need to purchase? And that's one thing that you kind of need to interpret yourself. It's like, well, if he's fencing a rectangle and he wants to buy the fencing, then that means he wants to know what the perimeter is. Okay, and so you could use the equation up above, or you can just say, well, there's 4 here plus 4 here plus, and you just add it up in your head. But if I use the equation up above, because I wrote it out, 2 times L we said was 25 plus 2 times, and now we found out that W is equal to 4, and so 2 times 25 is 50 plus 2 times 4 is 8, and so 58 feet. And it's actually not square feet, but again, that's a different video about talking about units and stuff. But it's just 58 feet. And so if he goes to Home Depot or whatever, I'm not trying to spout any store here, but if he goes there, he needs to buy 58 feet of fencing to complete this job. I'll just throw Lowe's out there too, just so it seems like I'm not kind of. And that's it. That's number 1, 58 feet, and that's let's see, that's B. That's the answer. If we move on. I said I was going to do every 4th problem, so I'm going to go down to number 5 now. And I want to do number 5 because it might be a little tricky for some people. Number 2, 3, 4, hopefully you can get those. If you don't, please come to the tutoring center. But let's move on. I want to leave you some tough ones to try on your own, so that you can get used to doing them without somebody guiding you. But if you look at number 5 tells us that Cody drops a ball off a cliff that's 200 meters high. That seems kind of dangerous that Cody's that close to a 200 meter high cliff, but he's there. The distance of the ball down the cliff is represented by the equation. So they give us an equation, so let's write that out. That's definitely a good thing to do. Distance equals 1/2 GT squared. So GT squared. So we have a couple of variables in there. All right, and if we, this is actually a physics equation, so they're using nice, good stuff that you may see later on. Okay, if I draw my cliff here, oh, that's not a very good cliff. That's kind of, yeah, there we go. All right, he says the cliff is 200 meters high, so this is 200 meters to the ground, or I guess I'm going to call that the ground zero, but whatever you do, it's 200 meters from here to here. Okay, and you got Cody standing up here, and he's trying not to fall off the cliff. He's reaching over and he's dropping the ball. And it says that how long will it take the ball to travel 122.5 meters down the cliff, right? So let's say, I don't know where 122, let's say that's 122.5. It wants to know how long it's going to take to get there. Okay. And then it gives us the g, which is, if you know physics at all, it's the gravitational constant, and it's roughly 9.8, and it's meters per second squared. So they give us that, and that's it, right? Well, something to kind of take out is they're saying how long, right? And these types of problems usually kind of make sense. And so as far as the variables that they choose, right? G is gravitational constant, D is distance, and T is actually time. And so what we're actually looking for is we want to solve for T. And that's what I do first. Before I plug in any numbers, I'm going to solve for T. So I'm actually going to erase this over here, and I'm going to I'll write it again over here. G equals 9.8, and that's meters per second squared. And I need to solve for T now. But the first thing I'm going to do is, again, you should be comfortable doing this based on the previous videos that we've done. I'm going to rewrite this as gt squared divided by 2, right? Because if I said gt squared over 1 and I multiply the two fractions together, I can get it like this. And the reason I do that is because now I can multiply both sides by 2 to get rid of the fraction. So 2d is equal to gt squared. And if you just kind of did that from this first equation without changing it into this one, fine, that's absolutely okay. I like to do that just to kind of show where I'm going, but as long as you get to 2d equals gt squared, we're good. So the next thing I need to do to solve for t is I need to take I need to divide by g. So now I have 2d divided by g is equal to t squared. And if I'm going too fast for you, or what I'm doing isn't making any sense, then I suggest watching some of the previous videos about how to solve for a given variable. There is a variable, and that's whether it's x and you got a bunch of numbers, or there's another video about multivariable equations, which is what we're doing here. And so if you need to watch that, that's okay. So now I have t squared. So how to get rid of the square? Well, again, based on those videos, I'm going to take the square root, and so I have to take the square root of each side. And so I get, and I'm going to write my t over here because I like my t on my left, but the square root of 2d divided by g. Okay, that's great, right? But I need a number because they're asking me how long it's going to take. And if you look at the possibilities A, B, C, or D, there's no like, oh, 2D. Like, no, they're numbers, right? And so now I'm going to have to say T equals, and there's another video called, well, I don't remember what it's called, but it's substituting in numbers for the variables, right? And so if you need to look at that equation or that video, that's perfectly all right. But I'm going to write this same equation out, except instead of d, what am I going to write for d? Well, they gave us two distances, right? They give us 200 meters to say he's on a 200 meter high cliff, but what they want to know is when the ball is 122.5 meters high, and that's the number that I want to use. So in fact, the 200 meter, the fact that the cliff is 200 meters is pretty meaningless, other than the fact that it's greater than 122.5. If I said, oh, I'm standing on 122, or if I said I'm standing on a 100 meter tall cliff, and there's not like a valley below that, and oh, how long does it take to get it to go 122.5 meters? Well, if it's only a 100 meter cliff, then that doesn't make any sense. So the fact that 200 meters is higher than that, that's great. But other than that, I don't care about the 200 meters. So they may throw in extra information to try and throw you off. On this test, typically they don't. So don't see information and say, oh, I probably don't need that. Right? You're probably going to use everything that. But in here, it's important to tell us that it's 200 meters because it makes sense that it has to be greater than the 122.5. But I'm not going to use that in my equation. What I'm going to do is I'm going to say 2 times 122.5. Oh, that's not good. Okay, 122.5. And then divided by g, and they told us what g was, and that's 9.8. I'm not going to worry about the units. If you're in a class, definitely they will mark off ridiculous amounts for not putting units down. So definitely put down units. And now I'm gonna simplify this a little more. That's equal to the square root of 122.5 times 2 is 245 divided by 9.8. 9.5. No, that's not it. And I don't like this question because unless they give you a calculator, and they may or may not. But if they don't, well, 245 divided by 9.8, I don't know what that is off the top of my head. And so what I would do instead, what I would, kind of, if I don't have a calculator, I'd say, well, that's kind of like, well, that's almost a 250, and that's almost a 10, and 250 divided by 10 is 25, so the square root of 25. And so this might not be exactly right, but it should be about 5, right? Well, reality is if you take 245 and divide it by 9.8, you get exactly 25. I don't expect you to know that. I don't know how they would, so I hope they give you a calculator on this test. But reality is, even if you're kind of like guessing, and I don't know that it's 5, I should say, oh, it's probably around 5, maybe 4, maybe 5, maybe 6. And if you look at the choices, right, A, B, C, or D, the other choices are 10, 12, and 15, right? So nothing even close to 5. So just by kind of guessing, you should be able to get close to 5. But if I had to guess, I would say that they'd give you a calculator on this test or on this problem. So moving on, because the answer is just 5 and our units is seconds, and if you carried units all the way through, you'd see that it would work out to be seconds. I said I'm going to do every fourth one, so I'm going to do number 9. Let me put some space down here. Let's see here. So number 9. And number 9 actually I like because it's real world stuff, right? You know, people always say, oh, how can I use algebra in real world? Well, you honestly probably use it a lot more than you realize. But in this case, I'm sure people do this on me in particular, you know, overdrafting. But it says that Nick has $90 in his checking account. So okay, I'm going to write $90. He makes purchases of $22 and $54. He overdrafts his account with a purchase of $37, resulting in a $35 fee. And then the next day he deposits a check for $185. So what's the balance of his checking account? Well, I start off with $90, right? And I subtract, because I'm making purchases, I'm going to subtract, and that makes sense, you know, if you're living in the real world, $22 and 54. So minus 22 minus 54. And there's different ways to do this. You know, you could say, you know, in parentheses, you know, but I'm just going to subtract each one separately. And then, well, if we did that math right there, we'd see that it'd still be a positive number. But it says he overdrafts his account with a purchase of $37. So he's purchasing something that's $37. So minus 37. That purchase resulted in a $35 overdraft fee, and that's a minus. You know, nobody's at the bank is going to charge you a fee for something. It's subtracting that money from you. So that's minus 35. And then it says the next day he adds a check for $185. What is the balance of his bank account? And really, you know, if you look at the answers, it could be positive or negative. So just because he deposited a check, you know, maybe he was negative $300. You know, you don't know. So we have to do the math. But look at the math right now, right? All I'm asking you to do, based on all the other videos and all the other stuff in this study guide, after we figured out what we're actually doing, I'm asking you to take some numbers and subtract them and then add them. Like, that's it, right? So this is pretty easy stuff, as long as you get to the point where you can figure out, you know, what they're asking, right? So if I take 90 and you know, without a calculator especially, it's very easy. You're like, oh, this is easy stuff. It's easy to kind of slip up on addition and subtraction. I do it all the time. But on a test, your professor is much more likely to be like, well, he knows what he's doing, and you just made a small mistake there. Multiple choice, you don't get that luxury, right? So 90 minus 22, just make sure you do everything correct. So 90 minus 22 is 68, a positive 68. And then from there, I'm going to subtract 54, right? And then, so 68 minus 54 is 14. And tell me if I'm wrong here. I'm just kidding. And that's good, right? Because he, you know, it said he didn't overdraft his account until he subtracted the 37 right there, right? So if I subtract 37 here, you know, whatever it is, it should be a negative number, right? Because I'm overdrafting it, it says. So I take a positive 14, I subtract 37, and I get a negative, let's see, 23, negative 23. Well, we'll see at the end if I'm right. So from there, I get a $35 overdraft fee, so now I got to subtract another $35. And when I do that, I get negative 23 minus 35 is, what is that, 58, minus 58. And then finally, I am adding plus $185 to it because I'm depositing, right? That should make sense that we're adding that money. I'm depositing $185, and so negative 58 plus 185, and I get, let's see, 27, positive 127. And if we look at our options, that is D. And it's important that C and D, right? They're the same number. There's one's negative, one's not. So it's important to kind of make sure you did your math correctly and you had the correct positive and negative signs, because it's very easy to get the same answer but negative, right? So it's positive 127. He has $127 in his bank account, so that's what his bank account is at. And so the answer is going to be D. All right, so moving on. Let's see if I doing every fourth one. Should be about number 13. There's some more math for you. 9 plus 4, 13. All right. And number 13. I don't like number 13. It's good because it's another like kind of real life situation where you might find yourself in that. But based on the wording, I don't like it. Based on the wording, what they're saying is they're saying that I'm paying, or she, Jasmine, $5,775 for a car, and if she pays 5% in taxes and fees, what is the actual price of the car, right? And so the question becomes, well, is she paying $5,775 plus, and then whatever the taxes, that 5% of taxes and fees is? And based on the answer, that's what they're asking, right? And so based on that, what we would do is we'd say, well, I need to know what 5% of $5,775 is, right? So I'd take 5,775, and then I'd multiply it by 5%, which in decimal is 0.05, and I can almost guarantee you, in fact, I could guarantee you that for this question, they would have to give you. I'm not expecting you to know 0.05 times that. That's ridiculous. But if you had a question, if you had a calculator, and we do that in our calculator, then I do 5,775 times 0.05, and I get 288.75. And so that's how much the quote taxes and fees would be, right? And if I'm paying that on top of what I paid, then I would say my final answer. Let me scroll this down a little bit. My final answer would be, well, the 5,775 that I'm paying plus the taxes and fees, so plus 288.75. And if we add that together, and again, you have your calculator there, so 5,775 plus 288.75, and that's 6063 plus, 0.75, right? And if we look at number A, which is what the answer is in the book, I mean, if you round that up to the nearest dollar, which I would do because I don't put any cents here, you get 6064, and that's what A is, and that's what the answer in the back of the book says. And hopefully that made sense as to how I did that. Like I'm adding that tax and fee, but really what the question is saying that she's making that payment of $5,775. So that makes it seem like that's the final payment. And then it's saying, well, if she's paying 5% in taxes and fees, what was the actual price of the car? The actual price makes it seem like, well, what's the sticker price of the car? And then I'm going to tack on taxes and fees and dealership, how they gouge or whatever, and the final price of that car would be $5,775 because that's when I'm making a single payment for that. If this is the answer here, and I'm making a single payment of $5,775, then I'm not done paying for the car, right? So that's why it doesn't really make sense to me in that wording. And here's why it's bad, because if what I would say would be and here's how I would set up like the second, how I would do it. Some price of the car, X, I don't know what that is, plus, X times that 0.05, right? Because what this represents is the taxes, right? 5% of whatever this, because if the car is, say, $5,000, it's 5% of that $5,000. That's what the tax is, and that's what we did up here anyway. And if that all equals to, let's see, 5,775, it's a little bit more difficult of a problem, but what I could do here, what I need to do here is factor out, well, I have X plus 0.05x, and again, I don't know what x is. That's what I'm solving for. So this becomes 1.05x, right? Because if this was a 1x and this was like a 2x, then I'd say 2x plus 1x, that's 3x, right? Well, instead I have a 0.05x, right? And so I just add that to the 1x over here, and I get 1.05x equals $5,775. And then again, to solve for x, I divide both sides by 1.05, divide by 1.05, and what do I get? Well, let's take a look at our calculator. We say 5,775 divided by 1.05, and what that becomes, let's see here. If you do that in the calculator, you get $5,500. And if that's not A, B, or C, or D, you might be like, oh, I did it wrong, right? But that's B. So if I was doing this problem, I don't know. I would say it was B, right? So there's two different ways to do it. The nice thing is, and that's not nice about this test, well, I've taken the test many times, and there's not any confusing stuff like that on the test. I mean, there might be confusing, but if you know what you're doing, there's one answer. However, let's pretend this was a class. You could always raise your hand, ask professor, and kind of get some clarification. That's always okay. You know, like ask him, well, is this the first, or is this the end payment, or I can kind of see where they're coming from this first half, and I see where they got there. It's just the wording is poorly worded. But that's how you would do it to get their answer. And unfortunately, like if you did this other way and you ended up getting some answer that wasn't on there, well, then I can kind of see where they might expect you to do it the first way. But since both of the answers are on there, I personally would do it the second way, and I would get that one wrong. According to this study guide, according to the test, again, I've taken the test many times, and I've gotten all the questions correct many times. I do it the way I feel like I should do it, and I've always gotten them right. So I hate to make a video, with a question where it's a cloudy answer, but I'm not going to just skip this one just because, then you can do it on your own and get the wrong answer and not understand. So if you end up getting 5,500 for your answer, I totally understand how you did that, and I would do that too. It's good math, and I wouldn't worry about getting something wrong on the test. So I think it's just poor wording. That's all. Going on, if I'm doing every fourth problem, then I'm going to be doing, let's see, 13 plus 4, 17. Number 17. Let's see here. All right, so number 17 shouldn't look too difficult. Okay, so it says the area of a rectangle, and again, I'm just going to jot this down, that area is equal to length times width, okay, because that's something you should definitely have in your head. And it says that the area is 160 inches squared, okay. And it says that the length is 12 inches longer. So let me sketch out a rectangle because I like doing that. And we're going to pretend that all the the two sides are the same and there's right angles and stuff. And it doesn't really matter what side you're going to call the length and what side you're going to call the width, as long as you're consistent. And so let's see. The length is 12 inches longer than the width. So I have a width here, and I don't know what that is, but I'm going to call it W. And then the length, well, I don't know what that is, so I'm going to call it, the length. But I do know that it's 12 inches longer than the width, right? So what does that mean? That means it's W plus 12, right? 12 inches. So whatever the length is, plus 12, that's going to equal my length. And then it says what are the dimensions. So I need to find W and L, right? And so I'm going to use the equation up here, the area equals length times width, and I write that in. Area equals width times, and then instead of length, I'm going to put W plus 12, right? Because if I think about this equation up here, and I actually write this out, that length equals W plus 12, well, then we got two equations, right? And based on the solving linear systems video, we know that we just take one and we plug it into the other one. And this one's already solved for L, so that's easy. So I take my L and I plug it in terms of the other variable, so W plus 12. And now I look and I see I got A equals W times W plus 12, and I got one equation and one unknown. So I should be able to solve for that. And now I know what A is, right? So I'm going to plug that in. So I got 160 equals, and then if I factor that W through, I get W squared plus 12W. And I haven't gone over this yet. I think it might be the next video or the video after, but we're going to have to factor this. And by factor, I mean not just pulling out the biggest common term. And that kind of factoring we're going to go over in the next few videos. So I hesitate to do this now, but I've already started. And for those of you who know how to factor, you can follow along. If it doesn't make a whole lot of sense, then I suggest watching the other video on factoring and then maybe possibly coming back to this one. But this is what we have, right? I need to solve for w. But since it's not a linear equation anymore, because I have a w squared here, I need to, we're gonna set this up in the equation that we want to think about is ax squared plus bx plus c equals 0. And that might scare a lot of people because there's a lot of letters there, but a, b, and c are just numbers, so don't worry about that. And x, that could be x, that could be w in this case, it could be y, whatever. But if I'm solving for x, I need it set equal to 0. So what I'm going to do is I'm going to subtract 160 from each side. And when I do that, I get w squared plus 12w minus 160 is equal to 0. And that's how we need it to look to solve for w when it's not a linear equation. And what I mean by that is that there's a w squared in there. And from here, and again, if you know how to do it, that's great. And if you don't, just try to follow along and come back if you need to after the next couple of videos that we learn how to do this. So I will be talking about this method in the factoring video. And if you know how to factor and you don't use this method, that's quite all right as well. But I call this the X method. I draw a big X. I put a little dot here, and I'll explain how to do this in one of the other videos in more in depth. But I put a dot there. I put a plus sign here. What goes up here is C, so whatever this first number is with no X next to it, times whatever this number here is next to the X squared or the W squared. And ideally, the number next to the W squared is 1, right? That's the best way to do that. And that may not be the case. You may not be able to get it like that. If it was like, say, a 2 here, well, I could divide everything by 2, and I could get it to be a 1. And again, I'll go in depth in the next video. But if it's like maybe, I don't know, a 7 where I can't divide it out, and you won't see a 7, but you might see a 3 or a 2. Sometimes you can't, and so you have to multiply those two numbers together. In this case, it's just negative 160 because what's next to the W squared is just the 1. Then down here, and you include that negative, right? So negative 160 times 1 is negative 160. Down here, it's whatever the middle number is, right? And that's just by itself, so whatever it is. And it happens to be 12 here. If it was a negative, it was like minus 12W, then it would be a negative 12. And then I ask myself, what two numbers, and I'm going to put them here and here, what two numbers multiply, because of the dot, to get 160, but add to get 12? And I know since the multiplication, since this one up here is negative, I know one of them has to be a positive and one of them has to be a negative, one of my numbers. And it's not the easiest thing in the world. What you got to do is you got to think about all the factors of 160, right? And so it would be like 160 and 1 times 1, 80 times 2, and then you want the difference between the two numbers to be 12, right? And one of them is going to be positive, one of them is going to be negative, and you definitely know that's not one of these two that I just wrote down because the difference is way more than 12. But in fact, if I put down a positive 20 and a negative 8, well then positive 20 times negative 8 is negative 160. Positive 20 times plus negative 8 is positive 12. And so I knew the bigger number, right, was positive because my number down here is positive. And so these are just kind of tricks, and I'll go over this more in depth in one of the other videos, but those are my numbers, right? Once I get those numbers, assuming that the variable in front of the coefficient in front of the W squared is a 1, I can simply do this. I make two sets of parentheses, and I put a W here and a W here. And I know that W times W is W squared, so I'm on the right track. If it was like a 3W squared, then one would have to be a 3, and it gets more complicated. We'll work on examples of those in other videos. But for this one, all you have to do is plug in what numbers you have. Plus 20 minus 8. And again, distributing, right, distributing this out, if I kind of use my FOIL method, and again, we'll go over that in the other video, but if I FOIL this out, I will get W squared plus 12W minus 160. And so we know that we're good here. And this is equal to 0. And the reason that we did this, the reason that we factored it, remember I said there's two reasons to factor something, and one is to be able to simplify it, and the other one is to be able to solve for something, is because now that I have two things times each other, this times this, and it's equal to 0. This is why it has to be equal to 0. It doesn't matter what this term over here is. If I can make this term right here on the right equal to 0, 0 times anything is going to be 0, right? So what I want to do is I want to say, well, when is w minus 8 equal to 0? And I'll solve for that. And because if that's true and w equals 8, then I plug that in and then that equals 0. It doesn't matter. I plug in w equals 8 over here as well, but it doesn't matter what that is because it's going to be times 0. It's going to be equal to 0. Well, the same thing is true about the right side equation. I don't care what this equation is, what this expression is over here. I don't care what it's equal to. If I can get this left side to equal 0, 0 times anything is going to be 0. So I also want to make this equation w plus 20 equals 0. Like when does that happen, right? And so I set each of those equal to 0. Each of my parentheses equal to 0. I solve for w. I get w equals negative 20 and w equals 8. And this is what's called solving for the zeros, negative 20 and 8. And so if I graphed this, like in my graphing calculator, that equation, it would cross the x-axis at negative 20 and 8. But as far as a word problem goes, it's asking what the dimensions are, right? It makes sense that the width could be 8, right? Okay, so if something's 8 inches long, and we're talking about inches now, but does it make sense that the width of something is negative 20 inches? Like, no, like there's no negative 20. I can't do that, right? And so I can just cross this one out. And so if I was just graphing, I said, what are the zeros, or when is it across the x-axis? Both answers would be correct. But when I apply it to word problems and stuff, only the ones that make sense are gonna be applicable, right? And so w equals 8, and that's my answer for that, right? So I know my width is equal to 8, and I also know that my length is equal to width plus 12, right? So my length is, width is 8 plus 12. So my length is equal to 20 inches. So it says what are the dimensions of the rectangle? And in particular, if you read the problem, if you're following along, it says in parentheses L times W, right? Because L is 20 and W is 8, our answer should be 20 times 8 per the problem, per the wording in the problem, right? And so that's B. And B is the answer, so we're good. If you look at A is actually 8 times 20, right? So it typically if you're asked for two dimensions, it's just what are the dimensions, and you just tell them it's 8 and 20, right? But in this case, it's important to put them in order that they ask you for, and they tell you length times width. So the answer is B and not A. And if you did the problem and maybe you paused it and you're like, I'm going to do this on my own, and you picked A, I fully kind of understand why you picked A. However, it's B because they want length first. And the same with C and D, they just switch those two. So if you got two answers, so just be kind of careful when you're taking a test. They might try and trick you like that, right? Like, oh well, technically I said length times width, not width times length. That's kind of dumb. That's kind of stupid. And if you're in a class, they probably won't nail you like that. But or I'll just ask you, what is the length, right? And you'll write down the length. And I said, what is the width, right? But when you're just putting two numbers down, it's silly to put one thing first. So the answer is B, 20 times 8. That's the end of this video. I would definitely work on all the other problems. I think the hardest part of this test altogether is the word problems, when really the math isn't so bad as you've seen in the other problems. This one, the math is a little, you got to do some work, but if you watch the other factoring video, it's actually not as bad as it might look. All right.